Alright, so we're back here looking at our vectors again, and we're going to look at just the problems this time. And so I need to kind of get myself set up here. I apologize for not getting, let's see, go to slide. There we go. So again, this is the problems part of our vectors. So now last video again, we looked at how do we take anything that's set up on like a northeast, south, west coordinate system and put it into a resultant vector, and how do we take resultant vectors and split them apart into components. And so I've got two different problems here, and we're going to walk through both of these problems to, again, practice seeing how to do this stuff. So I have a golfer, and our golfer is going to take 2 putts to sink his ball in the hole once he is on the green. First putt displaces the ball 6 meters east, and the second putt displaces it 5.4 meters to the south. So what is the displacement that would have put the ball in the hole in one putt? Okay, so here might be my green, okay, and here's my hole, and here's my, let's see, here's my ball. Okay, so the ball is going to be up here. So our first putt displaces it 6 meters to the east, okay, 6 meters to the east, and then it's 5.4 meters to the south. So we went again, north is this direction, and so we went north or east, then we went south, and we're now looking for what would be the resultant vector of these two. So if we wanted to make it in one putt, what would we have had to do? So again, you can see that this is going to form my right triangle, and I have the 2 legs of my right triangle, and I'm looking for the hypotenuse. So it's my a squared plus b squared equals c squared, and so I'm just looking at this in terms of what is the hypotenuse value. So I'm going to do 6 squared plus 5.4 squared is equal to c, square root of that whole thing. And we grab our calculators, and we do 36 plus 5.4 squared, and then we do square root of that answer. And so really the c value was just going to be 8.7, 8.1 meters. So again, the distance from here to here, 8.1 meters. That's the displacement that we would need to put the ball into the hole in one putt. Okay, and we would then look at this and say, well, maybe what would be the angle that we would have to be taken? And so we'd look at this angle maybe, and we could find that angle. Now again, if I'm going to do this, I'm going to try to do this without using numbers that I calculated. So I'm looking at this in terms of the side opposite and the side adjacent. So that's a tangent function. So the tangent of theta is equal to my side opposite, 5.4 meters, divided by my side adjacent, which is 6 meters. And so now I want to find the theta of this. So I have to do a tan inverse of this 5.4 over 6. So now to do this on my calculator, I take 5.4 divided by 6. That gives me my value. It comes out to be 0.9. I want the second tan of that answer, and that'll give me my angle in degrees, as long as I'm in degrees mode, of 42. Okay? So I want to putt the ball 8.1 meters at 42 degrees south of east. Okay? And so I usually say something like south of east to define for the reader or the person that's looking at my problem of where this angle is, where this is east and this is south, and so it's south of east. I know the phone's ringing. I'm going to let it keep going here because I got to finish up this video. I've got one more thing here, and I always have technical difficulties. And besides, if it's important, they'll leave a message. Looking at this next problem, we have a submarine that dives 110 meters at an angle of 10 degrees below the horizontal. And we want to figure out what are the horizontal and vertical components of the submarine's displacement. Okay, so I'm going to set this up and look at this in terms of my picture. So here's my submarine. Okay. Okay, there's my submarine, and it's going to dive 110 meters at an angle of 10 degrees below the horizontal. Okay, so there's my angle below the horizontal. So in other words, here's my water, and we're going to dive, and we're looking for the horizontal and vertical components. So in other words, what's my vertical component? I'll call that y. What's my horizontal component? I'm going to call that x. And this is my vector that I'm going down at that level. Okay, so again, this is now one where I'm splitting this up. So I'm going to find my y, I'm going to find my x. Now my y is my side opposite my angle. So the sine of 10 is equal to y over my hypotenuse of 110, or y is equal to 110 times sine of 10 degrees. So I go ahead and go to my calculator, do sine of 10 times 110, and this comes out to be 19.1. So I drop 19.1 meters. Now when I look at my x component is the side adjacent, so that's a cosine function. So cosine of 10 is equal to x over 110 again. Okay, so I get 110 cosine 10 is equal to my x value. So I'm going to solve that. So 110 times cosine of 10 comes out to be 108 meters. Okay, and so this is my x component, or my vertical component was this, my horizontal component was this. And so that's how we find our components of our displacement. Okay, so hopefully that gets you a good start on understanding vectors, and we'll take care of some more questions. We'll probably be working on practice problems tomorrow. I think there's a number of them that you can do now once you start to understand vectors. Till next time, happy physics.